Now that we learned so much about exponential functions, let's take a moment and compare the two functions we know so well, namely the linear functions from chapters 1, 2, and 3, and the exponential functions from chapter 4 and 5 as well. All right, so a linear function, remember, is of the form y equals mx plus b. The slope is your m, and your b is your y-intercept. Well, technically it's 0, comma b, but you get the point. An exponential function is y equals a times b to the x, where a is the y-intercept and b is your base, your constant multiplier. All right, so then let's look at what they look like in a table. So over here in a linear function, every time you move down the table, you'll add the same number. You need consistency, so it'll go 0, 1, 2, 3, or 10, 20, 30, 40, something like that. And then the y values, you will add or subtract a steady amount. That steady amount that you add or subtract is your slope. Exponential functions, however, as you add the same number every time for your x's, still consistent, but for the y's, you're multiplying by the same amount. Now keep in mind that could also mean division, right? Because if you're multiplying by a fraction, that means you're getting smaller and smaller. Multiplying by a number bigger than 1 means you get larger and larger. All right, then let's think about the graphs. Linear functions form straight lines, obviously. And there are two main types, those with positive slope that are increasing, right? And remember that the slope is rise over run, so they're vertical lift over their horizontal change, right? Or you could have slope being negative. Now, in order to write the equation of a linear function, those are the two things you need to know. You need to know your slope, which is m, and your y-intercept. Y-intercept, which is b. All right, then for an exponential equation, there are two main types. Well, actually, there are 4 types. Let me go back. These 4 types that we just saw in the last video from the previous section. But of these two, A and D are the ones that we deal with the most often for modeling. They're the ones where A is positive. So we have A greater than 0 and B is greater than 1. That's exponential growth. It's growing larger and larger. Or we have A greater than 0 and B is a fraction between 0 and 1, or decimal. And that means that it's exponentially decaying. Now, to come up with the equation for an exponential function, you're going to need to know 2 things. You're going to need to know the y-intercept, which is a for these, and the multiplier, the base. Let me put that. The constant multiplier, b. Those are the 2 things you're going to need to know. All right, which is obviously where we're heading. We're going to start finding equations for linear and exponential functions by hand. So we're supposed to look at all of these and determine whether or not these are linear or exponential. And if they are linear, then find the equation. And if they're exponential, find the equation. All right, so let's look at the first one. So what we need to know is, first of all, are the x's consistent? Good, they are. That's nice. And by the way, they're consistent over here for letter B, so that's good. Then are we adding or subtracting the same amount every time? Well, that's kind of obviously no. This is 42 for a difference. This is like 126 for a difference. So what about division? Well, I don't know. Let's check it out. So let me quit. Clear. All right, so let's take 1701 and divide it by, oops, I lost my screen there. No idea why that happened, but that's okay. All right, so 1701 divided by 567 is 3. All right, 567 divided by 189 is 3. 189 divided by 63 is 3. And 63 divided by 21 is 3. Okay, so we're obviously going down by a third. It can't be 3, because what you're doing is you're really dividing by 3, so that's multiplying by a third. So let's start off with, this is exponential for sure. And then the equation for it would be f of x is equal to 1701, there's your y-intercept, and then you're dividing by 3, so that's multiplying by a third to the x. There we go. All right, now what about this one over here? Consistent x is good. Now let's try for consistent adding and subtracting first. That would be linear. So from -8 to -5, that's 3. Then add 3 more and you get -2. Add 3 more, you're at 1. There you go. This is linear. You're adding the same amount every time. Linear. So g of x is equal to, all right, so mx plus b. M is 3 because that's what we're adding on every time. And our y-intercept is right here. It's 0, -8. See right there? This one was 1701. I'll highlight it for you. Okay, so there we go. That's a review question, of course, because we already learned how to find linear functions like that in chapter 2, I believe. Well, in chapter 1, for that matter. All right, so now what about the next ones? Letter C. Well, hopefully we all know just looking at letter C that that's linear, for sure. Let's see, what's the intercept? 1, 2, 3, 4, 5, 6, 7. So its intercept is at 7, so it's going to be plus 7. The slope is negative because it's going down, so you've got to count. 1, 2, 3, 4 down, 1, 2, 3 for the run. Because remember, it's rise over run, so we're going -4 over 3. Or if you like, -4/3. Double check yourself, though. Count from the next dot. So here over here, down 1, 2, 3, 4, over 1, 2, 3. So it's -4/3. All right. D is rather obviously neither, right? That's not linear and it's not exponential. That's actually an absolute value equation. The V shape is an absolute value symbol. All right, but not one we're dealing with right now. All right, E is exponential. You can see it has that classic exponential curve. All right, how is that going to work? Okay, exponential, remember, needs to have a form. I'm going to call this f of x here. It's going to be a times b to the x. Okay, but a is your y-intercept. So look at the graph, and you can see the y-intercept is at 4 right there. So it's going to be 4. And then now we need to do is figure out what we're multiplying by. So this is a little tricky. So 4 times something will get 8, and then 16 up here. So you can kind of see what it is, right? It's 2. So we're going from, here's 1 right here at -2. -2 is 1, then 2, 4, 8, 16. So if you think of it in a table, you're forming a table, right? 2, 4, 8, 16. There, I kind of drew you a table so you could see it. So 0 went with 4, 1 went with 8, 2 went with 16. So you can see once you make a table out of those points, that's totally exponential, and it's following this form. All right, now the thing about f is that it looks kind of exponential, but it isn't. Now there are only 4 exponential graphs. It's these 4 right here from the back of section 4.3. Right? None of these is the graph you're looking at. It looks a little like the one from C, but C doesn't stop at the y-axis. This one that we're looking at right here does. That's because it's not exponential. It's actually a logarithmic graph, which we will learn about more in another section or two in chapter 5. But this is neither for our purposes. Okay, so now let's get to some more interesting stuff. Okay, so you can see for these particular ones, do you see how I didn't give you the y-intercept here? Well, that's interesting. So I'm going to kind of put in some blank spots. Now, when you're following along at home, you can just kind of make the table kind of fake it up above yourself, right? But you want to know what's happening at 1. You want to know what's happening at 0. You want your y-intercept. We'll talk about it. All right. So now let's look at what's happening here. Are we adding the same amount every time, or are we multiplying? So 29 plus what would get you 41? 12, right? All right, 41 plus 12 makes 53. 53 plus 12 makes 65. There you go. So this is obviously linear. All right, now what is it? Y equals, f of x. F of x equals, all right, well, we can see that the slope is 12. So it's 12x because that's what you're adding on every time. But the problem is you don't know the y-intercept. And that's why I had us kind of fake the by hand stuff up here, fake the table, pretend the table was larger than it actually was. Now, there are other ways to do this, I grant you, but this is the way I'm going to do it for right this second. You could kind of finagle it and say, okay, well, if I'm adding on 12 every time to get down this table, then wouldn't I just subtract 12 to get back? Well, sure, right? So this would be 17. Subtract 12 again, and that'd be 5, right? Okay. Now I know what you're thinking. You're thinking, well, I would never have thought to do that. Okay, well, there's another way to get around this. Hold on. Oops, there we go, 12x plus 5. All right, so let me give you a different way to do it. So suppose you know that it's 12. You can tell that it's 12 just by looking at it. So it's y equals 12x plus b, something. If only you had, I don't know, a whole bunch of points that you could substitute in. Haha. So you could take 29 and 2 and put that in. So you could say 29 equals 12 times 2 plus b. That would be 29 equals 24 plus b. Subtract 24 from both sides, and you'll have that b is equal to 5. And therefore, f of x, or y if you like it, you can just say y. But f of x is equal to 12x plus 5. So that's how to do it by hand without having to fill out the rest of the table, if that makes sense. And it should work, but this particular one would also have worked just by kind of finagling the table up a little bit higher than we actually had it. But granted, you would only want to go a couple steps like that. All right, so I'm betting this one's exponential because otherwise it would be boring. Yes, we're obviously multiplying or dividing by something here. 12 divided by 6 gets 2. 72 divided by 6. Let's see, 72 divided by 6. Yep, that's 12. All right, so that's what we're doing. We're dividing by 6, right? Consistently. Okay, so this is exponential. Let's see if we can do this. So y is equal to a times b to the x. Now we can tell that it's got to be a sixth, right? So we know it's y is equal to a times 1/6. You can tell that because you can see you're working your way down, so it's got to be a fraction. And then you can tell because 12 divided by 6 is 2, 72 divided by 6 is 12, and so on. So all we need is to figure out a, and we'll be great. But we need an x and a y to substitute in. But we know that we have this xy pair right here, 5 and 2. So I can use that, and I can substitute. I can say, okay, 2 is equal to a times 1/6 to the 5th. Okay, 1/6 to the 5th, 1/6 to the 5th. Let's grab a calculator. If I take 1/6, parentheses 1/6, and I raise it to the 5th power, I get that number, whatever the heck that is. So 0.00012. Okay, so 2 equals a times 0.000128 and some change. Now I'm going to divide both sides by that number. And then I'll be able to find what a is. So these will cancel over here, right? So you're going to find what that number is, and we will divide away. Gone. They divide to 1. So you're left with a is whatever this number is, and we'll make the calculator find what that is. So do a squiggly equals because you'll be rounding. Now to make the calculator do this with all these decimal places, the easy thing to do is say 2 divide by second ANS. So it takes your last answer, which is here above the negative button. It'll take your last answer, which is all that, and take 2 and divide it by that. And it's 1552. So we didn't need a squiggly equals. It actually worked out perfectly. 1552. So then we know the equation is g of x is equal to 15552 times 1/6 to the x. And there's our final result. Oh, I better put that in a box because that's the final answer down here. Now that's how to do it by hand with using algebra. Then there's also a little bit of a number issue that you can use here. You can say to yourself, okay, well, if I know if I'm dividing by 6 all the way along, then wouldn't it make sense to work my way back up the table by timesing by 6? So I could just times 432 by 6. 432 times 6 gets me that number. 2592 times 6 gets me that number. It's faster, isn't it? Yes, I know. 2592 right here, and 1552, 5552. And then this part was the y-intercept. I'll make that orange so you can see it more clearly. And then this one over here. So it's kind of easier just to work your way up the table, but that's how to do it longhand if you had to. Both ways will work. It's just a question of how much work you want to do.